Good morning, everyone. Can you hear me correctly? Fine. Welcome to VMworld 2015. So I'm Julienne Pham. I'm going to co-present with Cormac, who's just sitting in front of me. So I'm working in VMware for 8 years. So today we're going to present conducting a successful virtual SAN proof of concept. So this is not the correct session. Just go to another one. So we're going through today. So this is just some disclaimer about the presentation, that we may contain some new features that are currently under development and some new technology and things like that from legacy and pricing packing. So today is the first things, Monday morning, 8:30, the first breakout session. We're going to learn something by failing to prepare, or you are preparing to fail, by Benjamin Franklin. So Virtual SAN was here and introduced early 2014. And there are a lot of experience, development, working with customers, working with R&D. So we try and work with Virtual SAN. So this session is all about what we see on the field, our own expectation, what we're seeing, and own experience. So we're going through the slides. We have only 45 minutes, so we can't tell everything about Virtual SAN. It's not possible, or every pitfall or everything. So we can only select some of the top issues, top things, top tips that we think it's very important for you guys. So we're going through the introduction, which I just made. So we're going through introduction for Virtual SAN, consideration of proof of concept of Virtual SAN, the tools available. We have a lot of tools because as we go along, we figure out that there are a lot of things that is missing, or it's very black box for some other people. So we have a lot of tools that is already out there or is working on there or in beta that we want to go through this presentation. The POC validation scenario, what's the top use case that we think is very important when you do a POC? When do you think it will fail, or when do you succeed? How do you measure that? Measuring a performance, you're comparing storage with your old application, with your old storage, and now you came up with a new Virtual SAN, and you're like, how does it work really, right? So we're going through, all the top tips, how to measure performance. Obviously, it might be not specific to your own application, but you can understand after that the logic behind it. And lastly, it will be moving from POC to production, because at the end of the day, you want to implement if your POC is successful, or if you think it's very valuable for your production company, you want to move that to production. So that will be the last part. So just quick question, just raise your hand. How many people install Virtual SAN? Just a couple of people. How many people do you think it's you looking to get more information to implement it, or have never implemented Virtual SAN? Okay, thanks, you have more people. So it's great, so just to have an idea. So as I said earlier, Virtual SAN was here for 18 months. So we did a lot of work. We put that in the beta. We worked with the communities, with a lot of customers to refine and make it more matured and production ready. And so now we will go through this session to give you all those outputs. So as of today, we have more than 2,000 people using Virtual SAN in their production environments. So in the 15 months, we did a lot of work. So it's a lot of improvement, a lot of work from both parties, from customers and even from VMware, to make sure that we align with what you're saying and just to make it ready. So we said Virtual SAN, I'm talking about Virtual SAN and so on, I'm just rambling probably, but what is Virtual SAN? So Virtual SAN is an object storage. And it was introduced basically with, you might see some challenge with a traditional storage where you're looking for what's the size of the LAN, how many LANs do I need for my VMs, will I have performance impact, What will I use NFS? Will I use iSCSI, fiber channel? All those things about designing a storage. Where what we are telling you now is you don't need to size your storage. You just add a new box, and basically it will scale out by itself. You just need to use and offload through the flash to have those performance. And everything, what we are looking for now is everything will be VM-centric, policy-centric. So we are looking to figure out which VM is the most important. Because you might have a lot of ESX, but all your VMs, not all of them are very important for you, right? You might have a DNS proxy, you might have a database, but which one is the most important and required a higher SLA than the other one? So this is basically the background where we move and introduce virtual SAN. So I might speak very fast, sorry. I have a French background, so if I'm really talking very fast, just raise your hands and I can slow down a little bit. So now we're going through the proof of concept consideration. So before going through installing, wow, virtual SAN is your new thing. I have all the bugs. I buy my flash, my hard drive. Now I need to go straight away, install it, and see how it works. But usually by experience, when you go straight and just, you issue a challenge every time. For example, the networking is not set up properly, your use case, or how do you measure performance and things like that. So I wanted to highlight it here. So what you need is to know is virtual SAN, what's your business case? What are you trying to accelerate in your production? What are you trying to accelerate in your business? Figure out which use case you're looking for. Is it for offloading for View production, View VMs? Are you trying to have more VM-centric, or probably go to infra as a service, like Vira afterwards, or VIO? Are you trying to offload that after on higher level, not only to transform your traditional storage to object storage? You have to see beyond that and see how at the end you want to consume it. After that, you need the planning, obviously. Sometimes you put people all together and you're trying to install virtual SAN, but at the end, you're looking to have a lot of barrier because the person is not the right person. He doesn't have the knowledge to install the networking of VMs or give you access to what you need. So sometimes you have a POC where you have a lot of delay. So planning is very important in there. And obviously, at the end, it's the outcome. You're looking for proof of concept, right? So what at the end, what do you want? What's the result? Is it just to see how virtual SAN is working? Are you trying just to see how it will fail or how it works or things like that? But what are you trying to achieve here? Next that we find is organization challenges. So I think it's not on virtual SAN POC, it's probably on all POC. So challenge especially for virtual SAN is culture barriers. So if we have a big organization, we have storage team, networking team, and operation team, OS team. You're like, yeah, I need a storage, but how are we going to work with virtual SAN? Because I can deploy VMs, I can change the SLA from vSphere, how it's going to change my administration, my day-to-day operation. I have the tools that I use every day, but it will not be familiar to me anymore. So virtual SAN is basically you have VMs and VMDK, all your data is spread across multiple servers. So what's going on, how I can manage it, how I can make sure that if something happens, I would be the first one to know how to fix it. And you have a lot of new tools coming up, new idea, new concept. So it's not like before you open a disk or you have just a hard drive and if something fails, you just put it back. No, virtual SAN have another concept, so you need to really abstract it. And this is maybe one of the big challenges that we see. Storage team operation, new methodology, like I said, new tools, new way to see and see things. And obviously, we do convergence between compute and storage. So this is where it's very important to see. The support. One of the challenges previously is you have multi-vendor support about storage vendors and things like that. Now with virtual SAN, I think the main contact should be VMware, right? To analyze and figure out what's going on. And at the end, they should normally handle it. The other part of the challenges of a POC is technical requirements. So you're like, well, how I can make sure that the size of the POC will reflect at the end my production or things that I'm doing. So regarding the hardware, the choice of hardware is very important because at the end of the day, your hardware is where all your VMs will be running on it, all your data. So you might have 3 hosts at the beginning, and after that, you can end up with 64 or multi-data center. So with this, and we recommend to have a uniform configuration just to balance all your objects because we don't have, it's not centric anymore. It's not one LAN, it's not one disk, it's not one storage. Here we're talking about multiple nodes, multiple area, multiple repository. So it's very complex one probably to figure out the idea and to figure out how to troubleshoot. It's just the way that we try to manage it so it should have more performance and more VM-centric. So that way, I don't know if you have seen, but we have a new compatibility guide where we figure out that now we have a VSAN ready node that we recommend you to at least go from the base, that we are sure that from this hardware, everything is supported, and from firmware, and also from drivers and things like that, and configuration. From networking side, obviously, from design perspective, are you going to share your network because it's going through a network with multicasting? Are you having a dedicated storage for virtual SAN? Are you using distributed vSwitch because you have probably 3 hosts initially with standard switch, but if you are hiding with 64, how are you going to manage how it's going to work, right? And obviously, one of the challenges is multicasting through all your network. Last point here is storage. So we have controller choice, very important because everything is local from your ESX server. So if your controller, if for example doesn't have enough queue depth, enough memory, it will be your single point of failure because it cannot access to your SSD the full potential, and eventually to your hard drive, HDDs. Obviously, you have also RAID 0 versus pass-through. So the RAID 0 is just a software extra layers. It just makes it harder after when you have to remove a hard drive, when you have a failure, for example, on the hardware side, you need additional operation from that part. Where pass-through basically is VMware is aware of what's going on and immediately detects if you change, for example, a hard drive, and things like that. SSD, HDD ratio choices. So if you don't remember, basically SSD is where you put all your cache, all the memory of your VMs. So first thing first, all your data goes through your SSD, has 30% of write cache also. So everything goes to your SSDs. If basically depend, and after basically it writes directly after your buffer is reached 30% to your hard drive. So it's very important to have an idea what's your ratio if it's capable. If your SSD is always full, it's writing on your HD, basically at the end you don't have the high performance that you should have. So it's very depending on performance versus endurance, and at the end, SAS expanders. What I need to be successful. So this part is about all the tools that is already released, so that we can go through. Here's a presentation of every tool, not every tool, the most common one, and when you want to use it, when you have to use it. So HAS plugin. So it first released recently in April, if I remember correctly. It's quarterly released. We agreed, VMware agreed that we don't have a lot of visibility in the past for people who are using VSAN. We have a tool called RVC, which is based on Ruby. So we're going to show that after that. But Health plugin is integrated to the vSphere web client and give you a lot of information from there, your cluster health, if you have one host is failing, your data store, even checking the HCL, if your firmware drivers, everything is up to date. Because we had in the past where the issue also could be on the firmware driver who didn't give you all the potential efficiency that you should have. So at the end now, here, you have an HCL already there that you can just look at your Health plugin on your web client and you figure out straight away if my virtual SAN is ready for production or is not, or something is happening. So you have also the data health, the networking health, and physical disk. So if one of hard drive is working or not working, you have a lot of testing also for performance. We will go through that in details after that. So this is some couple example of proactive tools that is already released. So maybe you cannot see, but for example, we have VM creation task. So you deploy your virtual SAN cluster and you want to see if I don't have an issue with creating VMs on all your cluster. You might have 3, right? You can right-click, you can do it on DRS and things like that. But here we're telling you that we can check on every host if we have any issue on any of them, and not only on one. After we have storage load test, so it's more performance. So we create VMs, we do Iometer, IO test, and we're showing also the result from the UI, just to make sure that at least you have a base of performance from your virtual SAN that you can measure and you can compare. Multicast performance tests, also, when you do any read-write, all your data go to your SSDs, but as depending of your storage policy, your data can be replicated to another one. So you need to write on through the network to another host to replicate your data. So multicast is very important because this is a transport layer when you do replication. The second tools is more the overview when something might be broken. So you go to the Health UI, everything is green, you do a refresh, everything is green, but your VMs, sometimes you figure out, it doesn't give you the performance that you should have, or something is going on, but the Health plugin basically didn't give you what you're looking for. So RVC give you more deep down level on each host about what's going on the driver level, on VM level, host level, VMDK, so it's very more deep down. Here you can't really see, but every time that it's red, basically it means that something is happening either on your network, hard drive, or something like that, that you need to focus, eventually call us just to troubleshoot, just to figure out something is wrong here on the driver level, on host level. We need to figure out what's going on. So here we have classified the RVC tools. So RVC tools, basically it's a lot of command line. You can find already out of the box from Virtual Center appliance and on VMware also. So you have those tools where you can either operate, because Health plugin doesn't operate on VSAN cluster, right? It's just for you to see how the health of your virtual SAN cluster. Whereas RVC give you more maintenance, more action on your virtual SAN. And it gives you also more, all the information that you see also on Health plugin basically come from RVC. So it's very UI and command line based. So we have released, which is in beta since 6.01, VSAN VROPS plugin. It's monitor smart information on your SSD if it's end of life or something like that. SSD hard drive, this performance comparing with your vSAN clusters. So you might have one vSAN cluster, but tomorrow you might have multiple. vSAN cluster is defined by ESX cluster. So for example, in your data center, you have one cluster, another one, and so on. You might have multiple virtual cluster. How you can monitor, how you can compare, how you can figure out what's going on. So with that, VROPS give you an overview through all that on more data center level, rather than vSAN cluster or ESX cluster or VMDK. They give you really an overview of what's going on. The final tools is a login site, which I find is really, at the end, when you have something wrong, when you have to troubleshooting, you need some kind of errors, some kind of triggers, what's going on. So everything goes through also, either you know how to log the VM kernel, or you just go on login sites. Login sites have already out of the box from vSphere virtual SAN endpoint, where you can figure out if there are some things wrong from there. If there are a lot of operation, a lot of tasks from virtual SAN, you might see from there. So now, Cormac will go through the validation testing scenario and performance.
Thank you. Good morning, everyone. So we've had all those conversations, we've prepared, we've planned, we've spoken to the management, they've had buy-in on doing a vSAN proof of concept, spoken to the storage team, they're happy enough with what you're going to do. So what we were looking at from what our field has experienced, I guess, around proof of concepts, is that these are the 5 most important things that we need to validate. I guess the first one is that we can actually configure vSAN. In other words, tie all the bits together, get the networking working, and create that distributed vSAN data store that spans all of the hosts. So just getting that configuration right, that's quite an achievement. And we've had issues with multicast in particular, the requirement to have multicast available across all the host networking. That seems to trip up a lot of the proof of concepts that we see going on in the field. And then the next thing is actually deploying virtual machines. Can we actually deploy virtual machines onto that vSAN data store? The next one is probably the thing that I think customers feel they need to test out the most, because we're now dealing with local storage on ESXi hosts. And we want to make sure that we can achieve the same availability for our virtual machines that we have on SAN or NAS arrays. So if we have a failure, will our virtual machine still be around? And in conjunction with vSphere HA, will it be restarted on the remaining nodes in the cluster? So testing out different failure scenarios is very important when you're doing a proof of concept. The next thing then is all about serviceability and manageability and these kind of day 2 operations. How does maintenance mode work when you have a node participating in the vSAN cluster? So when we put a node into maintenance mode, what happens to the data? What happens to the virtual machines that are on that host and on that storage? And do we take care of it? So you need to try that out as well. That's another thing you need to look at in proof of concepts. And the serviceability also boils down to things like what do we do when there's a disk failure? So how do we replace a disk? Those kind of things. And then last but not least, and probably the most complex part, is am I getting sufficient performance out of my virtual SAN cluster? In other words, when I deploy my workload on it, or if I plan to deploy a workload on it, how can I tell that it's going to give me the performance that I currently get with maybe my SAN or my NAS storage? So these are the 5 things we think are what we need to validate the most. And Julian was talking about the various tools that you have available. So what I'm going to do now is go through and demonstrate how we can use those tools to go through those 5 validation steps. So first off is deploying. So we had probably the biggest beta ever at VMware for virtual SAN 2 years ago. One of the issues we had is that Even though vSAN beta was available with vSphere 5.5, it was still a beta code at that point. It became GA at 5.5 update 1, but the number of customers who still ran 5.5 with beta code and logged service requests with us, there were quite a number of them. So the first thing is just to make sure that you're using the supported editions of vSphere. So it's 5.5 update 1 and above. Also, do you need licenses? Now we do have grace periods, periods. I think it's about 60 days or so. But you got to make sure that your POC completes within that time frame. If your POC is going to take much longer, then of course you're going to need to have the licenses to do that as well. I mentioned multicast already. Make sure you have those conversations with the network team. Make sure that network is in place and you have multicast and so on. And then there's the minimum number of hosts. Now, Julie mentioned that ideally you would have uniformly configured hosts, but we will support you having non-uniform hosts as well if you need to configure it that way. Then, of course, the devices. If you're going for vSAN hybrid configuration, you'll need a combination of flash devices and spinning disk on each ESXi host. But we also support all flash as well, so you can have 2 flash devices, one doing your caching, one for your capacity, if you so wish as well. Now, one of the common gotchas we've seen is the fact that customers have been using devices that may not have been on the HCL in the first place. They may not be running the appropriate firmware or driver versions. And this is where the health check really comes into its own. Because with the health check, you can compare your vSAN configuration against RHCL online. And you can do that test through the UI. So now you can validate whether or not you have a supported configuration just from the click of a button. So this is the list of health checks that we go through. As I said, there's an awful lot of checks that we do now. The health check is only available with 6.0, so it's not available for the 5.5 release. But I would urge you, if you are running 5.5, consider upgrading to 6.0 and getting this feature. The great thing with this feature is that as you go through a proof of concept and as you inject failures to see how vSAN behaves, to see how your virtual machines behave, you can come to this health check and see what failures have been induced. The other thing is that when you've remediated the problem that you previously injected, come back here as well, run it once again, and just make sure that everything is clean. So that's almost as important as putting the error in the first place, is making sure that you fixed it afterwards. The other thing we have is, so we mentioned also that we have some proactive tests associated with the health check. So not only do we have the checks, the reactive checks, let's call them, but there's also proactive checks. Now, the second thing we want to do, or customers tend to want to do out of proof of concept, is just make sure that virtual machines can be deployed on the vSAN data store. Great, we've put everything together. We've built that distributed vSAN data store. Everything looks good from a UI perspective, but can we be sure that everything under the covers is working? We don't have any disk anomalies or anything like that. The best way of checking that, deploy some virtual machines. And you don't even have to do that because we have a proactive test that will do it. So this first test that we're highlighting here will just roll out about 20 virtual machines across all the nodes on the vSAN cluster, make sure that they can be deployed successfully, and then it tidies up after itself if it can do that. And so that's checking a whole bunch of things. It's basically checking that the vSAN infrastructure is working well. Now, of course, vSAN has this distributed architecture. And when we deploy a virtual machine on vSAN, we have this capability, a default capability, where it will tolerate at least one failure. In order to tolerate this one failure, there needs to be 2 copies of the data. But where does vSAN place that data? If you select the virtual machine that you deployed, if you select the monitoring tab and the policies sub-tab, you can see exactly the layout of any virtual machine components that you've deployed on that vSAN data store. It will tell you which host a component is on. It will tell you which storage device a component is on. So this is a question that comes up a lot. How do I know that the virtual machine is rolled out with tolerating one or more failures, you can actually look at the layout of the virtual machine's components through this view here. So 3, this is the one that probably consumes the most amount of time, and this is just making sure that your virtual machine remains available as we inject failures into the system. So it could be, we piece out a host. What happens to the virtual machines that are on that host? Do they get restarted elsewhere? It could be that we've injected disk errors or an error on the flash device. What happens in that case? Or it could be that we just unplug the network or do something funky with the VM kernel port just to try and induce these type of failures. The thing with VSAN is it's completely interoperable with vSphere HA, so that in the event of any type of failure, the virtual machine could be restarted if necessary on another node in the cluster. So vSphere HA has a very important role to play. Now, one of the other features of VSAN is it's self-remediating. So in other words, if there is a failure, VSAN will try and rebuild the components belonging to a virtual machine elsewhere in the cluster. However, in order to do that, it will need at least 4 nodes. Now, we say a minimum of 3, and that's absolutely fine. But if you want to protect your virtual machine after a failure, you will need a minimum of 4 hosts. So things like, it might not even be a failure, it might even be maintenance mode. Maybe you need to update a patch or a driver on one of the ESXi hosts. If you only have 3 nodes in the cluster and you take one of those nodes out, well, your virtual machines are running with just 1 copy of the data and are at risk during that maintenance schedule. However, if you had a 4th host, you can evacuate one of the hosts that you need to do remedial work on. Your virtual machines will remain protected across the other 3 hosts, and you can do whatever activity you need to do on the 4th host at that point. So just something to bear in mind. Now, storage failures, there's one point we have to make, and this comes up all the time in proof of concepts. There's a difference between just pulling a disk drive out of the host and actually inducing a failure on a disk drive. If you consider this scenario, I have a very large vSAN cluster, and I have lots of hosts, lots of storage devices. And I know I need to replace a disk in one of my hosts. So I go into my data center and I pull out the disk, and then, oh, that was the wrong one. What's the thing we want to do? We just want to plug it back in, right? That's the thing we want to do. And that's what VSAN allows us to do. So if you pull a disk drive out of a host, there's a timeout value of 60 minutes before VSAN starts to rebuild any of the components that were on that disk drive. If the disk drive is reinserted in that period of time, then there's no rebuilding takes place. We just sync up the outstanding IOs that took place in that time frame. The same goes for a host, actually. So we have a 60-minute value because it allows you to reboot a host and not have any resyncing take place. So as the host rejoins after a reboot or whatever, then we'll just sync up the outstanding IOs from the time that the reboot happened. But now we do have a proof of concept guide that you're all going to read if you're going to do a proof of concept, right? Good, good. But we have in the proof of concept guide a mechanism that will allow you to inject a real-life failure into a device on the ESXi host, whether it's the spinning disk device or whether it's a flash device, and that will induce rebuild activity immediately. In other words, it's the difference between a component going absent and a component being marked as degraded. By injecting that error onto the disk device or onto the flash device, we'll immediately degrade that device. You'll see the rebuild activity taking place. If you have at least 4 hosts. Remember, 3 hosts, there's no way for us to rebuild. That's why, once again, it might be nice to do your proof of concept with 4 hosts to show that rebuild activity taking place. Multicast, very important. Julian already mentioned that. I think I mentioned it as well. It's a requirement currently on vSAN to have multicast on the vSAN network. But there's a test here as well that will test the performance of your vSAN network for you. It's another one of those proactive tests. And then the final point to make here is really about the rebuild activity. We now, through the user interface, we can actually see rebuild activity taking place. So if we have induced a failure of any nature, And if that rebuild timeout value has expired, you should see rebuild activity taking place through the UI. And this is available in vSphere 6.0 as well. And again, just test one thing at a time. Once you've tested it, fix it, run the health check, make sure everything is good to go, and then you can try your next failure after that. So maintenance mode. So we have a changed maintenance mode to work with vSAN. When you do maintenance mode on a vSAN node, you're given 3 options. There's the ensure accessibility, full data migration, no data migration. And what these basically mean is you just need to evaluate, do I want the host to be placed into maintenance mode as quickly as possible, or do I want my virtual machine availability to be at its maximums? So as you do maintenance mode and full data migration, what that's going to do is it's going to migrate all of the data off of the host that you're putting into maintenance mode and rebuild it elsewhere in the cluster. Again, you will need at least 4 nodes to be able to do this. You won't be able to do it with 3 nodes. The ensure accessibility option, just make sure that your virtual machine is available, but it might be available with just a single copy of the data. No data migration. That just means you're going to put it into maintenance mode, and whatever storage that's on that host is now going to go absent, and that could have an impact on your virtual machines, especially if it's been set up to tolerate no failures. So yeah, you'd want to probably try these out as well in your proof of concept. Just make sure that you understand how these maintenance modes are slightly different when it comes to virtual SAN. The other thing we've introduced in 6.0 is a bunch of disk serviceability features. You might think of them as simple things, but they're very important when you have a very large vSAN cluster, lots of spinning disks. The ability to be able to just turn on the LED on a disk that you want to pull out or change or whatever, very important feature. You can do that now just through the UI. So it helps you to identify that disk that you really want to remove from the cluster. There's a bunch of other ones there as well. I won't go into them in too much detail, but we have done a lot around disk serviceability. The one other thing we have as well is the ability to be able to evacuate data on a per disk basis or on a per disk group basis, or obviously through maintenance mode on a per host basis as well. Now we come to the most difficult one, and this is virtual SAN performance, or how to measure that. And this becomes the most complex one, to be perfectly honest. So there's a lot of different application type workload performance tools out there. VD Bench comes to mind. There's a bunch of others. But what's the one everyone goes for? Iometer, right? Just because it's the most easiest. The only thing with Iometer is it's very synthetic like workload. It's not real life. So you have to do a little bit of tweaking around Iometer in order to have it perform like a real life workload. And so that's where we tend to have to provide a lot of guidance. What I would say is that we do have there's a nice blog post up on the vSphere blog site, or the storage blog site, that just talks about how you would do performance testing. If you're interested, that's worth a read. But if we go with Iometer, which tends to be a very popular choice, what are the kind of considerations we would have to have around that? So the first thing is that vSAN is distributed. So what that means is that when you deploy a virtual machine, it's only going to access the compute of the host that it's running on. It's also going to be accessing the storage of the host that it's running on. So really, in order to properly test out the capabilities of your vSAN cluster, you're actually going to have multiple virtual machines deployed across multiple nodes in the cluster as well. The other thing is that vSAN is a caching mechanism, and you're going to get the best performance out of vSAN when your working set is sitting in cache, okay? Which for vSAN is flash. It's sitting in flash. So how to achieve that? The thing with Iometer is that you typically just give it a disk drive, point it at a disk, and let it do its thing. But if you have a very large disk, if you point Iometer at a 100 gig disk drive, it's going to try and consume that a whole 100 gig disk drive. And that's not going to sit well with vSAN because vSAN is trying to cache your working set. And now you've just given it a 100 gig working set, which typically isn't what your application would have. So what we recommend is you have a very small, maybe 4 gig VMDK or something like that, something that we can actually save or store completely in cache, so that that working set is getting the whole of the benefit of having vSAN in cache as well. The thing with, if your working set is not cached, what will have to happen is vSAN will have to go, especially in hybrid systems, it will have to go to the capacity layer and fetch the data from the capacity layer, which is typically spinning disk. And in that case, you're going to induce additional latency and so on. Next thing, is the workload cache friendly? So if you have sustained sequential write workloads, that's not typically a cache friendly workload. What you're looking for is repeat patterns and that kind of thing. So that's the other thing to think as well. Think about that. Make sure that you have a workload that's maybe cache friendly. And then finally is the cache warmed. So once you initially launch Iometer against a vSAN data store, or if you launch it in the VM that's running on a vSAN data store, all of the initial blocks are going to have to be read from the capacity layer because they're not cached. So what we would say is leave Iometer run for a while, half an hour, something like that. What you'll see is a big spike initially for read cache misses, and then that'll all start tapering off. And it's that point that it's actually simulating your real-life production workload. So we do say just start off small. So, with Iometer, you can have single workers or multiple workers. So start off with a single one. Make sure that you have a small working set, a small VMDK that you're pointing Iometer at. Have that all in cache. Select the cache-friendly workload, maybe 70-30% read-write ratio, random access. Outstanding IOs is another one as well. Where typically, if you're working with SAN or NAS arrays, outstanding IOs, you can have very large outstanding IOs because things like host bus adapters, they have queues in the thousands. We're working off local SCSI or storage adapters, I should say, and they're typically, the queue depth is in the hundreds. So we're saying tune down the outstanding IOs as well, and you can tweak that as you go along too. Block size, just try and make it simulate the most common workload that you have. And then whether you have a guest file system, do you want to write raw, or do you want to have a file system on there as well? So again, just to recap, the cache warming should be a consideration. You could also consider striping the virtual machine. For those of you not familiar with vSAN, we can lay out the virtual machine as a stripe as well. And then one last thing is, how does the performance look when you introduce an error? So how is the performance of your virtual machines when there is rebuild activity also taking place? Something else to consider. So I think I've done Iometer to death. You just start off small, but then you can start tweaking things as you go along. Okay. How are we for time? Sorry, are we okay? Anyone got the time? Quarter after, thank you. Yeah. So we have about 15 minutes left, that's good. Great. Okay. So the one last thing I wanted to point out with the performance tests, and Julian mentioned this already as well, is we have this ability through the proactive tests on the health check to run performance tests against your storage. Now the great thing about this is it will give you an idea of what your virtual SAN configuration can do for you, but you can also look at this as a type of burn-in test. So let's say we've set everything up, we've run a couple of tests, things seem to be okay, now we're finished for the evening. You know what we'll do? We'll run this burn-in test for overnight. Let's run it for 16 hours, and let's see what things are like in the morning. What that means is that if you've had something that's just maybe a little bit flaky or something, could be a controller, could be a disk drive, running this sustained burn-in test may pull that out for you. And so if you do get a failure, run it again. If it's the same disk drive, well, more than likely that's the root cause. If you start seeing random disk drive failures, maybe there's something funky going on with the controller, worth investigating. So that's a useful thing to have as well. So hopefully that's given you an idea of how we can, how we can validate virtual SAN in your environments. I mean, hopefully those 5 different scenarios will help you through if you are considering doing a proof of concept. Again, I would reiterate, we do have a proof of concept guide. You can find it on the VMware.com website. That has all of this information in far greater detail. It's worth taking a read of that. So I'm just going to hand back to Julian just to talk to you about, we've finished the POC, what are the considerations of moving into production, and then we can have a Q&A after that.
Thank you, Cormac. So the last section is from POC to production. So like Cormac said, the POC guide is great, but the troubleshooting one is even better. So the other consideration to take place when you go through production is design for scaling, right? For today, you have maybe 3, the next day, you have maybe 5, and the other one, maybe you have 2 or 3 data centers with all virtual SAN. So you have to make sure how you want to deploy also your ESX deployment. If you want to have a script installed, other planning also for capacity planning, and also how you want to do that. Next thing is about the operation, like Cormac said, maintenance mode, how you want to operate maintenance, what type of workflow, how you want to operate that if you have a hardware failure. Third-party tools, so for controller RAID where, for example, you have a RAID 0, you need to install those third-party tools on your ESX box to see the LED, for example, to highlight when something is broken or and you need to change. And all those VSAN operations like rebuild, resyncing that you need to be aware of. You have the monitoring part, how to set up alarms. VSAN by default, the alarms are disabled. So you need to set up which alarms you want to set. And use eventually VROPs or even virtual SAN health plugins to monitor more likely on your VSAN cluster on different levels. And finally, not last, HA disaster recovery. So now with the new VSAN, we have the stretch cluster that we support, how you want to define that. After we have the use of vSphere Replication and SRM, how you want to protect, how you want to have a disaster recovery. Because virtual SAN, it protects on the ESF cluster on your site base, right? But if something happening, how do you do backups and disaster recovery? So that will be the end. So if any of you have any question or anything, you can come up, or
yeah,
we have mic,
microphones.
or you can come up at the end of the session.
Is there any questions? Yeah.
Early on, you mentioned that scaling your scale-out architecture. Do you have anything in place that I have a hardware cluster that I could actually scale up as this SSD, or is that not supported?
No, you can absolutely scale up as well. So the way the storage is designed is in a disk group concept where there is one flash device and up to 7 capacity devices. So you can certainly introduce new disk groups. If you so wish, we support a maximum of 5 disk groups on a host. So if you wanted to introduce new flash devices and new spinning disk devices and scale up rather than scale out, you can most certainly do that as well. You're welcome.
So looking at the future, do you see, I remember reading something about a month or so ago about smart virtual SAN, whereas you would actually be able to isolate storage for building versus storage for production. And is that something that VMworld or that VMware is looking to do? I mean, or is that, whereas you've actually got isolated SSD sitting out there simply for the purpose of maintenance, support, building of new images versus having to use your production environment?
So are you asking like almost like hot spare?
Yes.
Yeah.
Well, yeah, but smarter than that.
Right. So there isn't really the hot spare concept like we know it today. So there's no devices that are just set aside in the case of failure. The way we look at it is the whole of the cluster is like a hot spare. So if there is a failure of any type, we can rebuild elsewhere in the cluster. And then you just replace that failed component and rebalance the virtual machines as necessary.
And I get that as far as repair, but I'm talking about just day-to-day support, building new images, rolling out, because I mean, some of the demands I have is to roll out hundreds of images at a time. When I roll out hundreds of images at a time, I'm using all my available cache and SSD within my environment.
Right.
If I could take a section of that volume of
Data
resources
Yep.
and be able to allocate it only for rollouts versus impacting my production environment.
Got it. There's no feature like
Nothing
that, no. Not at this time,
Well,
anyway.
that's a recommendation.
Okay. That's good. Thank you. Yes, go ahead.
Yeah, in a potential hybrid situation, does it integrate with the current SRM environment?
So,
What do you mean by, well, SRM, yeah, SRM will work with this.
Can you build a whole thing, or can you integrate it with what you have?
so with vSphere replication, so you
Yeah.
can use vSphere replication. It was actually, I think, one of the, there's a bunch of announcements going out today about VSAN 6.1. One of them is interoperability with vSphere replication to do replication across different VSANs, and you can certainly orchestrate that with SRM for sure. So there's no what's the term used, the array-based replication plugin, the SRA.
SRM,
There's no
yeah.
SRA for VSAN, but certainly with vSphere replication with SRM orchestrating on top, you could do it that way. Indeed.
Yeah.
Why not HCI bench?
Sorry.
HCI bench, you guys created an entire benchmarking framework for hyperconverged.
Yes. So I'm not quite sure what the question
What-
is.
me too.
So VSAN definitely is this, part of our HCI story, if you like.
But you guys actually created a benchmark for hyperconverged infrastructure. That's a modification for VD bench.
I'm not sure I'm getting the question. Sorry.
Well, it's just
my fault.
why not use your own benchmark as part of the POC?
Oh, I see. So the reason we talked about Iometer is because everybody wants to use Iometer. And, we'd love if people would use these application representative benchmarks and loads. We would definitely want people to use something like VD Bench or something like that, because that gives you more real life type workloads. But
mean-
unfortunately, Iometer is what everybody uses, which is why we talked about it.
Yeah, it's like every tool, right? If you know how to use it, you pick the one that you know how to use it because you know how to measure at the end of the day. So we have a lot of customers having their own test use cases. Even they want VMware, but they're not confirmed at the end. They're not, they're not validated. They don't feel that it is what they represent their workloads. So usually, like you say, they use Iometer because they know they measure that on physical box and virtual box. They think it will be the same. So every tool is how you're familiar with it.
Got it.
Most of them.
Yeah. Thank you. Yeah.
Right, my question is kind of getting back to the RAID. So these are basically RAID 0 containers.
Correct.
So I have two containers that are RAID 0, but I fails over the other container, right?
So the reason why we have RAID 0 is that there are certain controllers that will not surface up raw devices. You need to wrap them in a RAID 0. So when we talk about RAID 0, we mean taking individual spindles on the host, putting a RAID 0 configuration around them, and allowing the controller to see them. So what you end up with is if you have 6 physical disks in a host, we see 6 RAID 0 configurations. And the only reason we talk about doing RAID 0 is that unless we put a RAID of some sort on those devices, ESXi won't be able to see them, or they're not surfaced up by the controller.
So the hardware RAID behind that doesn't count, like the little hot spares and things like that.
Correct. So the only supported configuration will just be individual spindles put in a RAID 0 configuration, and surfaced up to the ESXi host. You're welcome.
Could you elaborate more on a stretch cluster? I'm looking at a data center with stretch VLAN and be able to have nodes in different data centers and bypass the whole SRM and just have an, active kind of scenario.
Yep. Announcements on VSAN 6.1 later today. You should definitely keep an eye out on those because there's something around that's being announced.
That would be on the main.
You know what? I think somebody's blogged about it already on the vSphere storage blog. Just Google VSAN 6.1. It'll tell you all about it.
All right.
But yeah, stretch clustering, it's in.
Coming up, yeah.
All right. Thank you.
You're welcome.
Yes, do you support like replication products like Zerto or PowerPath Virtual Edition?
Yeah, well, we wouldn't support them, right? But,
No, but I mean,
sure.
can I use this with Virtual SAN?
So I think you'll have to ask Zerto. I mean, I know Zerto, they're in a lot of vSphere environments. Whether there's any nuances around vSAN, I simply don't know. But those guys are here in the Solutions Exchange. So,
Okay.
yeah,
Thank you.
Thank you. Any other questions? Yeah.
Yeah, if we don't have additional hardware to be able to test, say I have a large staging environment, I don't want to do it in production, obviously, and we have database servers that require a lot of I/O, which we're servicing now with Fiber Channel. If I wanted to, am I able to sort of hybridize my cluster? So I have, say, 20 ESX hosts running 6.0, and I want to try using the vSAN product. Can I cut the node, can I cut it in half and say, okay, I'm going to slide disks in and maybe half my array, my PCs, and then say maybe I can do a storage vMotion of some of those things over to that vSAN to see if it will perform as well. If it does not, then we'll just take it off and put it back.
Yeah, absolutely. So, so you can continue using any other storage in conjunction with vSAN. All you'll have to do is you've got to make sure that, so you won't be able to take one of your SAN devices and use it as a local device for vSAN. So you're going to make sure that the hosts that you use will have that local spinning disk, a local flash device, so that you can build your vSAN data store that way. But you won't be able to leverage your SAN or NAS storage as a backend for vSAN, if that makes sense.
No, I just talking about moving it back and forth so that
You can
Yeah,
move,
so
you can move back and
I
forth.
don't want to stick disks into all my machines, for example.
Yeah, you can absolutely migrate workloads between the different storage types for sure, fully supported. Yeah.
Can I have a VM on a non-vSAN? Like I don't have any disks in that machine, for example, and no local cache.
So yeah, so again, that's coming back to, we would highly recommend uniform configurations, but you can certainly have computer-only nodes in the vSAN cluster which can leverage that vSAN data store. Yeah, awesome. Well, thanks very much, folks,
Okay,
those of you
thank
that
you.
stayed.